All right, everybody, we are looking today at the 1-9 notes. We're talking about the absolute value parent function, okay? That phrase I want to focus on at first, that phrase parent function, all that means is that we are talking about the simplest possible version of an absolute value function, okay? And you're going to see in the later lessons that the reason it's called the parent is because you can find variations and different versions of absolute values that are all based on this original one. But as for right now, we're just going to be talking about this one single function, okay? The parent function of absolute values. So what I've done is I went ahead and filled in the first page of the notes right here. On the left column, we have all of these x values. Okay, x values on a graph, and what I did here to get these y values is I substituted in those x's to see what we got as y's. Okay, I substituted them in to this function right over here. Okay, this is something you did in Algebra 1. You evaluate a function, you plug in your x value to see what you get as a y value, and then you plot the point, okay, with the x and y coordinate. So on this one, I took the absolute value of -5, and we know the absolute value of -5 is +5. So that's where I got that 5. Same thing, the absolute value of -4 is +4. So I went down and did that for every single one of them. All of the negative values output positive y values, and all the positive x values output the same, positive y values. And we end up with a shape like this. Our graph is shaped like a big V. Where it goes straight down. It's got a little turnaround point right down here, the vertex, and then it starts going back up. And actually, that's what we see on the next page. We see a couple of quick definitions: the axis of symmetry and the vertex point. The axis of symmetry is a vertical line. When you're talking about an absolute value function, it's a vertical line that splits the figure into two parts. So it's pretty easy to tell that the axis of symmetry is that vertical line that goes right through the middle. It is also the vertical line that goes through the vertex. Okay, the vertex being the place where it turns around. Okay, that turnaround point down at the bottom right there. It's either the highest or lowest point on the graph. Okay, so let's talk domain and range. Okay, domain on this one, when I talk about how far to the left and how far to the right, I can see that we've got arrows on both ends. Okay, that tells me that our domain is positive or negative to positive infinity. In fact, on every absolute value function, it's always going to be that same domain. Your range, however, on this one is not the same, because the range is measuring the y values from bottom to top, okay? And we can see that down here at the vertex, it does in fact bottom out at a single spot. That lowest y value is 0, and it goes up to infinity because we've got arrows pointing upwards on both sides. Now, our x-intercept and y-intercept on this one are both pretty simple. The x-intercept, where does it touch the x-axis? That's at 0. The y-intercept, same thing. Where does it cross the y-axis? At 0. The axis of symmetry is this vertical line right here. And this vertical line has an equation of x equals 0. Okay, and the way we can know that it's x equals 0 and not something else is we look at the coordinates of the vertex. Okay, the coordinates of the vertex, talking about this little red point down here at the bottom, right there, that has coordinates of 0, 0. And so when we look at the coordinates of the vertex, we see that the x value is 0. Well, that's exactly what the axis of symmetry is going to be. That 0, those two zeros that I highlighted in yellow are the same thing. They come from the same fact that all of the x values right there are 0. Okay? Is it a maximum or a minimum? You can see that as we go across, we're going downhill this way, and then we stop at that vertex and start going uphill. Okay, it's the lowest down point. It must be a minimum. Okay, so those are all your key features of this absolute value graph. What I want to talk about specifically is the minimum and maximum points on a given interval. And there are some problems like this that are going to come up on your DCA, and that's why I'm going over it right now. Okay, what I want you to do is when you look at this graph, What the problem will do is the problem is going to give you an interval. Okay, the interval, all of these intervals that are given are x values. And what we're going to do is we're going to look at this graph and we're going to look in between, we're going to look specifically in between the values of -3 and 0. So what I mean by that is I'm going to look at this graph and I'm going to draw a line, vertical line at -3 and a vertical line at 0. The stuff in between here, okay, this part of the graph is the only thing that we are worried about. We do not care about the rest of this, all this business, for the purpose of problem number 1. We are only interested in this middle piece. And it is asking the question, what is the minimum and maximum value on that interval? Okay, and it's talking about the y value. So it's saying what is the lowest y value and what is the highest y value on this chunk. Okay, so the lowest y value is going to be the one that's down here at the bottom. That y value is 0, so that's our minimum. Our maximum in between those two vertical lines is up here. The highest y value that we reach in that chunk is 3. So that's our minimum and maximum. Go on now to number 2. Okay, on number 2, I'm going to do exactly the same thing. I'm going to take my little highlighter here, and I'm going to mark off in between 3 and 5. We are only worried about this piece of the graph. We don't care about all the rest of this for problem number 2. Okay, our lowest y value is 3. Our lowest y value is 3. Our highest y value up here is 5. So that's our min and max. On that interval, our minimum is 3. Our maximum is 5. Okay, let's do number 3 and 4. We'll skip 5, 6, and 7. Call it a day. All right, number 3 gives us the interval from -2 to +1. From -2 to +1. So I'm going to clear this off again. In between the values of -2 and +1. We don't care about any of the rest of this. We are only interested in this piece of the graph right here. Our minimum value, the lowest down that we ever reach, is at this point. Okay, that is an a y value, of 0. The highest that we ever reach is up here at +2. All right, so that's our min and max on that interval is from 0 to 2. That's our min and max, 0 and 2. Look now at number 4. We're going from -5 to +4. That's our interval that it gives us for this problem. So I take my highlighter and I draw the line at -5, and I draw another line at +4. Okay, we're not worried about this piece over here. We only care about the function from right there to right there. So the question, what is our lowest y value? Well, once again, it's this one down here at the bottom. An x value of 0 is our lowest. So that's our minimum. And our highest would be this one all the way on the left side. It's the highest up that we ever reach at +5. Okay? All of the questions on your assignment are just like this. They are asking, what is the minimum and maximum on the given interval? So what I want you to do is, if you need to draw vertical lines and outline the chunk that you're doing, you can do that. You could take your hands and cover up the parts that you're not interested in and make sure you're only looking at what's in between. Okay, whatever you need to do to make sure that you're being careful about watching for that interval. That's the whole purpose of that section. All right, that's going to be all of the notes for today. Y'all have a good